express the sum in sigma notation. So I have negative 1/5 plus 2/5 minus 3/5 plus 4/5 minus 5/5 plus 6/5. And so we're thinking to ourselves, what patterns do we see? Well, we certainly can see these terms are alternating. I have negative, positive, negative, positive, negative, positive. So we have alternating terms. What else do you see? So we see on top of these terms alternating that we have the sum of the integers 1, 2, 3, 4, 5, 6 that are all divided by 5. So we have the alternating sum of the first 6 positive integers. You could abbreviate as that double bar z with the plus. So the alternating sum of the first 6 positive integers divided by 5. So we want to go ahead and rewrite this given sum here to prove to ourselves that what we're claiming is actually happening. So for a moment here, let's ignore the alternating portion. So we just want to consider the positive terms. Right? So let's say that we have 1/5 plus 2/5 plus 3/5 plus 4/5 plus 5/5 plus 6/5. So we can see here, if we just think about the positive portions, we can see the sum of the first 6 positive integers, and they're all being divided by that constant 5. Right? So if, again, we're still ignoring that positive or negative, so we can think of this is the sum from k is 1 to 6 of k by 5. So that's if you had just the sum of these positive integers 1 through 6 divided by 5. But we know that that's not what we're given here. We have the alternating portion. So let's reintroduce the alternating terms. So we want to reintroduce the positive and negative and see if we can relate this to the sum that we just quickly found. All right, so we have, again, minus 1/5 plus 2/5 minus 3/5 plus 4/5 minus 5/5 plus 6/5. And again, looking up at our first case here, we know that we have the portion of our sum that's changing are those first 6 positive integers. So we want to relate those to the alternating portion. So looking at our first term, we can rewrite this as negative 1 to the first multiplied by 1 by 5. Actually, we should give ourselves a little bit more room here. So we can rewrite this as negative 1 to the first multiplied by 1 divided by 5. And see, I'm matching the power on the alternating portion to the numerator of our fraction. Then we have plus negative 1 squared multiplied by 2 divided by 5. So again, the power of the alternating portion matches the integer in the numerator. And we can continue with this. Plus negative 1 cubed multiplied by 3 divided by 5. Plus negative 1 to the, not negative 4, should be negative 1 to the 4th multiplied by 4 divided by 5. And again, we can see how the powers in the alternating portion match the integers in the numerator. And we have 2 more terms. We have negative 1 to the 5th multiplied by 5 divided by 5 plus negative 1 to the 6th multiplied by 6 divided by 5. And so again, these last 2 terms, we have the power of the alternating portion matches the integer in the numerator. And this is from where k is 1 to k is 6. So we can rewrite this in its compact sigma notation. We have the sum from k is 1 to 6 of negative 1 to the k multiplied by k divided by 5. And so again, this is just one of many possible answers here.